We're right on the edge of a massive change in how we talk to technology. For years, chatting with AI has felt, well, pretty awkward and clunky. But all of that is suddenly changing and changing fast. So let's break down how we got from clunky robots to conversations that actually feel human.
Have you ever been trying to talk to a voice assistant and it just feels painful? Like you're on a really bad walkie-talkie call where you have to say your piece, stop, wait, and then it talks. It's that frustrating feeling we've all had, right?
And this right here shows you exactly why. On the left, you've got real human conversation. It's fluid, it's messy, it's fast. We interrupt each other, we talk over each other, we finish each other's sentences. But on the right, that's the old AI way. It's strictly turn-based. You talk, you wait. It talks. It's just a completely unnatural stop-and-go way to communicate.
So, what was actually going on under the hood to cause that maddening delay? Let's take a look at the old way of doing things.
Okay, so the old method was what's called a cascaded pipeline, which is really just a fancy way of saying it was a slow three-part assembly line. First, your voice had to be turned into text. That's step one, ASR. Then, a large language model, the LLM, had to read that text and figure out a response. That's step two. And finally, that text response had to be converted back into audio. Step three, TTS. Each step added more and more delay.
But honestly, the lag was only part of the problem. By forcing every single thing through this text-only bottleneck, the AI lost all the really important stuff. The emotion in your voice, your tone, whether you sound hesitant or excited. It was only getting the words, not the feeling behind them. But now, a totally new architecture called Moshi is here, and it completely changes the game.
And the magic behind it is a concept called Full-Duplex. Now, that sounds super technical, I know. But all it really means is that the system can listen and speak at the exact same time, just like a real person does in a conversation. No more waiting for your turn to talk.
So what Moshi does is it just throws that whole slow three-step pipeline right out the window. It uses one single unified speech-to-speech model. This means it's hearing your voice and generating its own voice at the same time in parallel. It completely gets rid of that text bottleneck in the middle. And the result of this new approach? Wow. The response latency just plummets to 200 milliseconds. Now, to give you some context, the average human response time in a conversation is about 230 milliseconds. So yeah, this is actually faster than us. Okay, so Moshi cracks the code on making conversations feel natural and super fast, but there was still one big catch. It was stuck with just one single fixed personality.
And this quote from NVIDIA just nails the problem perfectly. For the longest time, you had this impossible choice. You could either have a custom AI that was robotic and slow, or a natural-sounding AI that was totally generic. You couldn't get both.
This is exactly where the next big step, PersonaPlex, comes into the picture. It takes that brilliant, natural-flowing foundation from Moshi and adds the one thing that was missing, a totally customizable personality. So now you get that natural flow, and you get to decide exactly what kind of voice or role you want it to have. And this isn't just some abstract idea. With just a simple text prompt, the AI can become a calm, reassuring bank agent trying to help you with a declined card. Or it could be a patient customer service agent for a doctor's office. It can even become an astronaut's co-pilot, adapting its tone and stress level during a reactor core meltdown. This all sounds absolutely incredible, right? But you've got to be wondering, what kind of raw horsepower does it take to actually run these incredibly complex, real-time conversations? Well, it takes a staggering amount of power. We're talking about hardware like the NVIDIA H100 GPU. And to put this number in perspective, a T-flop is 1 trillion operations per second. This chip can do nearly 1,000 of those every single second. That mind-boggling speed is what makes this kind of natural, real-time conversation even possible. And here's where it gets really clever. To hit those insane speeds, these chips use something called lower precision math. Just think of it like using rounded numbers instead of super exact decimals. For a conversation, you don't need perfect scientific precision. What you need is incredible speed. And as you can see here, that trade-off gives you a massive boost in performance, which is absolutely what you need for a real-time response.
And look, to make sure these systems are actually delivering on their promises, engineers use standardized tools, like NVIDIA's GenAI Perf. It measures things that really matter, like the time to first token, which is basically how fast the AI starts talking, and requests per second, which tells you how many conversations it can juggle at once. You have to measure what matters. Okay, the tech is seriously impressive, no doubt. But let's bring this all back home. What does this massive leap forward actually mean for you and me? Well, it means that conversations with AI can finally feel, well, like actual conversations. This chart shows you the success rate for handling tricky stuff like interruptions and smooth turn-taking. PersonaPlex nails it over 94% of the time. That's a huge improvement over other models. And the difference in speed? It's just as dramatic. Just look at the average latency here. PersonaPlex responds in about a quarter of a second. That's nearly 5 times faster than other leading systems. I mean, that's the difference between an interaction that just flows and one that feels like it's constantly buffering. So let's just quickly recap the big takeaways here. We've made this fundamental shift from those slow robotic pipelines to fluid, full-duplex conversations. We can now give these natural-sounding AIs unique, custom personalities, and it's all being driven by unbelievably powerful new hardware and verified with precise industry-standard benchmarks. This shift is way bigger than just better voice assistants. It's a move away from just giving awkward commands to actually having genuine dialogue. And that opens up a whole new world for how we interact with technology every single day. So it leaves us with one last big question. If AI can now truly talk like us, what in the world are we all going to talk about next?